Whether you know it or not, physics is an important part of everyday life. Physics can be defined as a natural science that involves the study of matter through space and time. This involves the study of concepts such as energy and force, and many more. So, physics can help us to understand important everyday concepts such as sight. So today we'll be taking a close look at the eye. Why is sight important? Well, first, sight allows us to connect and interact with our surroundings and the people around us. It also helps us to remain safe in particularly hazardous situations, and it keeps our minds sharp and aware. Before we can understand the physics behind sight, we must first develop a knowledge of the anatomy of the eye. The cornea is the transparent layer that forms the front of the eye. The pupil is a hole found in the center of the iris. The lens is a transparent biconvex structure that is held in place and stretched by the ciliary muscles. The aqueous humor is a transparent water-like substance that fills the body of the eye and supports the lens. The retina is the inner coat of the eye, which acts as a light-sensitive layer of tissue. Finally, the optic nerve carries sensory information to the brain for processing. The eye has three main functions. First, the eye acts as an optical system that focuses on incoming light. Second, the eye acts as a diaphragm to adjust the amount of light that enters the eye. Third, the eye acts as a light-sensitive surface to detect a resulting image. So, how does the eye work? Rays of light move through the air, which has an index of refraction of 1. They move into the cornea, which has an index of refraction of 1.38, and are bent so that they hit the lens. The lens, which has an index of refraction of 1.44, bends the rays again through the aqueous humor until they converge onto the retina at the back of the eye. This image that is formed is then sent through the optic nerve to the brain for processing. The eye accommodates for distance by changing the shape of the lens. In order to focus on a distant object, the ciliary muscles pull and lengthen the lens, allowing the light rays to converge on the retina. The ciliary muscles remain relaxed in order for the eye to focus on close objects. There are many defects that can affect proper vision. Some issues include astigmatism and glaucoma. Today we will be focusing on hyperopia, myopia, presbyopia, and cataracts. Hyperopia, or farsightedness, occurs when a person's eyeball is shorter than normal, causing light rays to form a blurry image behind the retina. This is usually corrected using convex lenses and glasses. Myopia, or nearsightedness, occurs when a person's eyeball is longer than normal, causing light rays to converge and form an image before it can hit the retina. This is usually corrected using concave lenses and glasses. Presbyopia occurs when lenses lose their flexibility and the eye is unable to perform accommodation to focus an image. Now for a real-life example. This is my mom. My mom has very poor eyesight due to myopia and presbyopia. As a result, the distance at which my mom can see an object is different for each of her eyes. Her optometrist uses a treatment tool called monovision. This means that she wears one contact lens that corrects only distance vision in one eye and one contact lens that corrects only near vision in the other eye. Corrective lenses are prescribed not by focal length but by refractive power. The refractive power of a lens is the inverse of its focal length. In my mom's case, her left lens has a refractive power of -7 diopters. The negative indicates a convex lens with a focal length of -14 centimeters. Her right lens has a refractive power of -5 diopters. The negative indicates a convex lens with a focal length of -20 centimeters. Here is another real-world example. This is my dog Dixie. Dixie is a 12-year-old border collie. In her old age, she has begun to develop cataracts in both of her eyes, which greatly affects her vision. Cataracts develop when the lens of the eye becomes greatly clouded. When the lens is not clouded, light is able to refract freely through the lens and onto the back of the eye at the retina. When cataracts develop, light becomes scattered or blocked by the clouded lens. As a result, the light is unable to converge to form an image at the retina. This causes blurry vision in cataract patients. The best correction for cataracts is cataract removal surgery. The eye is a very intricate and precise system. In order to understand the eye, how it works, and how it malfunctions, it is first important to understand the physics of light, lenses, and sight. So, now you know.